We are studying variables and expressions. Algebra uses symbols to represent quantities that are unknown or that vary. Let me get my marker here. We use things like x or y or z, okay? Or we can even use a star or a box. It doesn't matter, it's a symbol or a variable, symbol or letter that represents the value of a variable quantity. Now, vary means to change. Variable means changeable. So that's why we call it a variable, is because it's changeable depending upon the equation that you're using, okay? A numerical expression is a mathematical phrase that contains numbers and operation symbols, but no variables. So if you look down here, we've got 3 plus 2, number, and an operation symbol. 5 minus 1, number, operation symbol. 8 divided by 4, number, and operation symbol. And the same thing over here. This is 6, and whenever you have a number up against a parentheses, that means multiplication. So 6 times 7, that is a numerical expression. Now, an algebraic expression is a mathematical phrase that includes one or more variables. Remember, a numerical expression was a mathematical phrase that included numbers and operation symbols. Okay, so now this is going to have an algebraic expression is going to have a variable included. So what do we have right here? We've got 5 times x. Whenever you have a number up against a letter, that means multiplication. So we've got 5 times x. Over here we've got 3 minus y. And if it involves a variable, then that means that it is an algebraic expression. All right, your turn. You tell me, is number 1 a numeric or algebraic expression? Yes, it's algebraic expression because it has a variable included in it. Number 2, numeric or algebraic? Right, this is numeric because it only contains numbers and an operation symbol. Alright, notice that we're using vocabulary like phrases and expressions. That's just because algebra is a language just like English or Spanish or any other language. You just have to learn to speak and interpret algebra. So learning the vocabulary of algebra is very important. What is an algebraic expression for the word phrase below? Now we're going to start translating words into algebra. What is an algebraic expression for this word phrase? So we write 32. How would you represent more than? Okay, more than is plus, because if you say, what is 2 more than 0? That would be 2 plus, okay? 2 more than. Okay, so this is 32 plus a number n. 32 plus n is what we would write. Alright, what is an algebraic expression for this word phrase? Either one of these word phrases. A number n, so we write n, minus, we write minus, and then the number 58. n minus 58. Most of the time you can just write things, most of the time you can just write things as they appear in the word phrase that you're dealing with. This is an example of one that you can't do that on. This is 58 less than a number n. So if we write 58 less than a number n, would that be correct? Now let's think about this. What is 2 less than 3? 2 less than 3. Well, if we've got 3 and we have 2 less than 3, we would have 1. How did we get to 1? We went 3 minus 2. So this does not work. So if we see if we see less than, we got to remember we got to switch the order of the letter and the number, okay? So this would not be 58 minus n. This would be n minus 58. If it ever gets confusing, you just go back to using numbers, and that way you can figure out how it should be when you're using a letter. What's an algebraic expression for this word phrase? 8 times a number n. Well, we write 8 times a number n. So you could write it like that. We do not write 8 times n. The reason you don't do that is because we're going to be using the x as a variable, and so that would be confusing. For example, if it was 8 times the number x, so if it was 8 times x, this is what it would look like, and we can't have that, okay? So we're going to be using this way of writing multiplication, or you could write 8n, or if you had to, you could write 8 times n like that, okay? Okay, what's an algebraic expression for the word phrase below? The quotient of a number n and 5. Quotient means division, so you can write division, quotient of a number and 5. Or you could have written that as n divided by 5. Okay, an algebraic expression for this word phrase. This one's a little bit more complicated because it involves more than one operation. So we've got 3 more than twice a number. Twice a number, what does that indicate? What operation does that mean? Twice something, that means 2 times something. So that would be 2n, okay? Alright, so let's go to the next one. An algebraic expression for this word phrase. 9 less than, oh, do you remember that one? Okay. Remember when it says 9 less than, you've got to switch the order, okay? When it says less than, you've got to switch the order. So we're going to come over here and we get the quotient of 6 and a number. The quotient of 6 and a number. Quotient is division, so it's 6 divided by n minus 9. So it's 9 less than the quotient of 6 and a number. What is an algebraic expression for the word phrase below? The product. Product means what operation? Product means multiplication. So we're going to go the product of 4 and the sum of. So you're going to be multiplying 4 times the sum of something. So we've got to put that sum in parentheses. The sum of a number, x, and 7. Now why did you have to put it in parentheses? Because if you go 4 times the sum of a number and x, it would look like this. And that would only multiply the 4 times the x. It would not multiply the 4 times the 7. See, this multiplies the 4 times the x plus 7. Over here it only multiplies the 4 times the x. So when it tells you the sum of a number and x, you're going to put it in parentheses. All right, your turn. Write an algebraic expression to represent the following. 3 more than a number, 5 less than 3 times a number, and the quotient of 6 and the sum of a number and 2. Pause the video for me. Do these 3, and then after you're through, come back and we'll see how you did. All right, 3 more than a number. 3 more than a number. 5 less than 3 times a number. 5, once again, less than means you're going to be switching the order. So 5 less than 3 times a number minus 5. The quotient of 6 and the sum of a number and 2. So quotient means division, so we go division, the quotient of 6 and the sum of a number and 2. There we go. How did you do? I hope you did well. What word phrase could you use to represent the algebraic expression 3x? A word phrase. Now this time we're going backwards, okay? We've been going from the word phrase to the algebraic expression. Now we've got an algebraic expression and we're going to be going to the word phrase. So we've got 3x. What could we say that would describe that in words? We could write the product of 3 and a number, or you could write 3 times a number, or you could write 3 multiplied by a number. Oh, one more. You could write triple a number, because triple means 3 times. Alright, what word phrase could you use to represent the algebraic expression 10x plus 9? Alright, well, we could write the sum of 9 and the product of 10 and a number. That works. That's the sum of 9 and the product of 10 and a number. You could have come up with other things, but that's one way that you could do it. Alright, suppose you draw a segment from any one vertex. Do you know what a vertex is? A vertex is here where 2 lines meet. Okay, that's a vertex. And the plural of vertex is vertices. Alright, so suppose you draw a segment from one vertex of a regular polygon to the other vertices. Use the table to find a pattern. What is a rule for the number of non-overlapping triangles formed? Let's see what we're going to do here, okay? So let's go. You could have started anywhere, but if I draw a line, you know what, I can draw a better line than that. Let me get a line over here. So if I go from here, to here. Alright, now the question is, if I draw a line from one vertex to all the other vertices without overlapping, okay, so that means I draw one from here to here, but if I draw one from here to here, it overlaps this other one. So how many triangles do I have now? 1, 2. So we come over here and we write number of triangles, 2. How many sides were there? 1, 2, 3, 4. Alright, the next one. So we've got from here to here. Oh, I should have used my better drawer, but I didn't. We can go from here to here. Now if I draw from here to here, or here to here, then that means they're going to overlap. So how many sides did we start out with? 1, 2, 3, 4, 5. And how many triangles do we have? 1, 2, 3. Alright, last one. There are 1, 2, 3, 4, 5, 6 sides. I bet you can probably figure out how many triangles there are going to be, can't you? So let's do this. So here we go from here to here. Here to there. And here to there. 1, 2, 3, 4. Alright, now the question is, give a rule in words and use it as an algebraic expression. What is the rule for the number of non-overlapping triangles formed? If I have 4, I form 2 triangles. If I have 5 sides, I form 3 triangles. If I have 6 sides, I form 4 triangles. If I have n sides, that means any number of sides. How would I figure out what the number of triangles was? Well, what's the relationship between 4 and 2? How do I go from 4 to 2? Right, I go minus 2. 5 minus 2 is 3. 6 minus 4 is 2. So this would be n minus 2. That's how you come up with a rule. Alright, some key words that you're going to have to be aware of. More than means plus. Fewer than means minus. Quotient means divide. Less than means minus. Sum means plus. Of means multiplication. Difference means subtract. Product means multiplication. And minus means subtract. Learning the vocabulary is going to make it easier for you later on whenever you have to do word problems. And you just got to translate the words into algebra. Okay, but if you don't know the vocabulary, you're not going to be able to do it very well. So make sure you get these into your memory.